Welcome to the AI for EU Cafe. Today, it's the first cafe after a long summer break. I hope you all had nice holidays, and I will present today Andrea Micheli. He's researcher in automatic planning and scheduling at Fondazione. I'm not good in Italian. Fondazione Bruno Kessler from Italy, with his talk on AI Plan for EU, bringing automated planning to practitioners and to the European AI on Demand platform. So I'm seeing already you're all coming in. Again, welcome. My name is Carmen McWilliams, and I'm the moderator and organizer. I'm the director of Grassroots Arts and partner in the European AI for You. This is the AI on Demand platform project. And please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speaker and only the speaker express their personal view and opinions, and also decides if the video gets recorded and published afterwards. So important, it's always here the speakers are deciding what will happen. What is the cafe? The cafe is an online forum to gain insight into the European AI scene. Participants get the chance to share knowledge and experience and network with each other and meet stakeholders from various areas of AI research and application. And it's interactive, so if you have questions to the speaker, please always write it. It's on the right side, you see a menu, you can write text questions in there. I will read it to the speaker afterwards. So again, welcome, and I will now introduce Andrea Micheli. Thank you, you are here. Hello, we see you.
Hello, thanks for having me.
It's great you're here. And I will now read shortly your CV. Andrea Micheli is a researcher in automated planning and scheduling of Fondazione Bruno Kessler in Italy. His research focuses on the development and technology transfer of planning technologies for the digital industry. He obtained his PhD in computer science from the University of Trento in 2016 with a thesis titled Planning and Scheduling in Temporarily Uncertain Domains that won several awards. The Euro AI Best Dissertation Award, the Marco Cadoli Prize for Young PhDs, the FBK's Best PhD Award, and an honorable mention of the ICAP's Best Dissertation Award. So impressive, and it's a pleasure to have you here today. You are belonging to the next generation of a lot of talent, and great that you're here. And now I will give you the floor. It's up. You can now, I change the moderator, or introduce yourself and feel free to present.
Okay, I hope you can see my screen.
Yes.
Super. Fantastic. So thanks a lot. Welcome everybody. Thanks also for the very kind introduction. So I'm Andrea Micheli. I work at FBK, is a research center in the northern Italy. We are in the Alps. And today what I want to present to you is an overview of this European project that is titled I Plan for EU. It's an ICT 49 project. So we started this January, we started this year, and it's a 3-year project. The aim of the project is to contribute to the AI for EU platform. So, and what we want to contribute is AI planning. So before, let's say, starting, let me give you a little bit of introduction of what planning is and what we mean by automated planning. So automated planning is one of the foundational techniques in AI, and it can be described pretty simply. So you give a model of a system, so a description of what a system that can be a robot, it can be a factory, it can be an healthcare procedure, right? What the system can do. And you ask the planner, you ask the reasoner to find a way to reach a certain goal that you describe. So for example, if you have a robot, you can say, okay, please bring me a coffee from the kitchen, and this is the goal. And then the job of the planner is to find out a way for you to get the coffee, given the capabilities of the robot and the characteristics of the environment. So this is the way automated planning can be described in a very general way. And this, let's say, simple description can be applied to very different applications. So it can be used again in robotics. So you want to plan or also coordinate the activities of robots. So if you have more than one robot, one interesting problem arises from the coordination problem. So finding a way to cooperate between machines in order to achieve a more high-level goals. That is, let's say, more expressive, more powerful than what a single robot can do. And so the value of planning in this context is to give you flexibility and robustness when you create automation. So instead of, let's say, programming every single detail of the motion of the robot, or to pre-program all the, let's say, the capabilities, right, by hand, what planning allows you to do is to automatically synthesize these plans, these strategies, in order to achieve a given high-level goal. So it gives you flexibility. Then there is also the point of optimization. So if you imagine, for example, the system being a factory, and what you can ask a planner to do is to plan the activities in a factory. So I want to construct a certain amount of items of a certain kind, and so what you ask the planner to do is to maximize the production and minimize the cost, given the workforce that you have, given the capabilities of the machines, possibly minimizing the use of resources, right? So the idea there is to exploit the capabilities of the machine in order to optimize and organize a complex system like a factory. And another example could be instead to minimize the environmental impact, for example, by organizing the agricultural practices. So, you know, do some kind of targeted spraying instead of simply spraying the entire field. You can have a planner to organize when a certain machine should be utilized so that you can exploit it better. And you can, for example, minimize the soil compaction by driving on different paths so that you don't have a part of your field that gets compacted too much, and many others. So, and actually one of the interesting part of this project is really to find interesting new and relevant application for planning. What I would like to convince you today with this talk is that planning is really a fundamental pillar of AI, and it needs to be present in AI for EU. And that's exactly what you know, our project is advocating. We believe that planning resources and capabilities are vital needs for a platform that aims to, let's say, cover the entire spectrum of AI technology. And so the job of our project is to reinforce the platform by bringing planning as a first-class citizen. So that's what we want to do in very abstract terms. More concretely, we set out 6 quite, let's say, ambitious innovation goals. First one is to make planning more accessible to practitioners and innovators. The point here is that differently from, for example, from machine learning, we have quite a fragmented landscape. So there is no clear, let's say, winner technique that is better than all the others. And also, in order to experiment with different tools, it's quite costly. We don't have like a Keras library, for example. The aim here will be to construct something, create an artifact that allows you to easily experiment with different tools, so that you can, if you are a practitioner or you are a business owner and you would like to use planning technology, what you would like to do is to test before you buy. So the idea will be to make it cheap for you to experiment, not only with planning itself, but with different planning techniques. And by testing, you can figure out whether, first of all, planning makes sense in your field, and second, among the different planning techniques, which is the better one or the one that can give you more value or that is more efficient. So that's our first goal. Second goal is to facilitate the integration of planning with other ICT technologies. So in many cases, in the literature in particular, we start directly from the planning problem, and then the job of the researchers is to find good ways, efficient ways to solve the planning problem at hand. In reality, though, the planning problem is not given. It needs to be constructed by harnessing some kind of data from probably an existing ICT infrastructure. So, for example, if you want to automate the logistics of a warehouse, you need probably to interface with an existing warehouse management system and gather data from that system in order to create the planning problem, and then you can then use a planning techniques in order to solve it, and then you need to bring back the solution that the planner hopefully gave you to the level of abstraction of the WMS, so the warehouse management system. And so here the problem that we identified is that there is no common API. There are different formal languages that are being used by different planners. There are different dialects of the same languages, and so we need somehow to create an homogeneous way of interfacing, because otherwise it becomes a problem of integration with other ICT technologies. That's something that we want to overcome. Third objective is to make planning relevant in diverse application sectors. I mentioned before some, let's say, more classical areas of application for planning, that is logistics. For example, we have several works in robotics. Robotics probably is one of the, let's say, major application areas that you can find in the literature. But as you will see later in this presentation, we identified several more, and we think that there are many others to be discovered. So there are different domains of interest. And also some planners are general purpose, others are specialized. But let's say if you look at the literature in particular, very few application sectors have been considered, or there is, just one paper talking about the application of planning in that area. We need to make a more coherent overview of where planning can make sense, and to try also to invest or to convince the stakeholders in that application sector to invest in planning and to take advantage of the existing planning technology. Fourth is to integrate with the AI4U platform. As I said, we strongly believe that this is quite something that is missing there. There are a lot of technologies that is centered in machine learning, other forms of reasoning, but planning itself is kind of missing. And we really think it's important because it's a foundational subfield of AI. Fifth is to facilitate the learning of planning in order also for allowing reskilling and lower the access barrier to the technology. The problem here is that you can find a lot of planning material online concerning planning. There are courses, there is documentation, there are papers. The problem is that we have quite a steep learning curve, because it requires some specialized background knowledge in order to access the technology itself. So it's not easy for someone to try it out, even to try small, let's say, example problems. And this is something that, in our opinion, needs to change in order to allow more people to understand what planning is, what you can do with it, and again, to make it possible for the other objectives. Finally, let's say to give back something to the research, and in particular, if we are able to find interesting application sector, we would like to use those in order to define interesting problems that maybe are not solved, or the current technologies are not efficient enough to address, and so bring back these directions towards academic research, and try, let's say, to create a strong link between practitioners and academia. So, and again, here the point is that current research is well aware of some of the applications, but we think there are many more that we can learn from. Okay, so given all these innovation goals that I presented, how can we solve it, right? So what is the first step to do? We have a grand vision in our project, and the grand vision is summarized in this infographic. So the idea is to have a number of use cases, right? And the one that you see listed here are the ones that we already have within the project. So we already have one company representing that specific use case. So we have logistics, we have agriculture, flexible manufacturing, fleet planning, meaning organizing autonomous vehicle, a fleet of autonomous vehicles. We have the problem of human-robot interaction, subsea robotics, lab planning, so organizing the experiments in a lab, plus, as we will see also later, we have the possibility of adding more use cases by means of cascade funding. So there is also the opportunity for those of you that might have an interesting use case to present to contribute and let's say add a layer in this orange stack. Given a use case, what we recognize is that there is the need for bridging this use case with the planning technology. That's why we have these technology-specific bridges on top. What we mean by that is to have some kind of software artifact that are able for a certain use case that uses a certain technology to transform information, data in that domain into a planning problem, and to translate back a solution coming from a planner to that use case. So to give you an example, if you work, for example, in logistics, right, there are different warehouse management systems that you might use. One of those is called Manhattan. If you happen to use Manhattan, then we can create a software artifact that in general, for the way Manhattan represents the logistics problem, right? We can transform it automatically into a planning problem, solve it, and then translate back the solution into a set of actions to be applied within the representation of Manhattan. Similarly, if you happen to be in robotics and you use ROS, so the robotic operating system, we can do similar thing, right? We can transform the sensing information plus the action information from within ROS into a planning problem, and then transfer back the planning from the planner level to the robotic level, let's say automatically. So the idea is to create a set of these technology-specific bridges, one for each of the technology that we encounter, and not only, let's say, use them for our own evaluation, but make them available so that others can use the same or reuse or adapt these bridges, let's say, glue code that allows you to transform domain-specific problem into planning generic problem. But in order to have, let's say, a suitable target problem, since, as I mentioned before, there are different planning engines that have different characteristics and capabilities, what we have is an abstraction layer. We call it Unified Planning Framework, or UPF for short. The idea here is to abstract away the characteristics of the different planning engines into a unique representation format. And then let's say, dispatch the planning problem in this general format to one or more of the planning engines and transfer the solution back. So the idea is that this UPF, this Unified Planning Framework, acts as an abstraction layer for multiple engines. So you can create easily portfolio or parallel solvers, or you can do automatic solver selection given the characteristic of your problem, or simply experiment with multiple planners without changing the code that creates the planning problem, but simply asking the UPF to use a different planner for solving it. And so this makes it cheap to test different engines, different configurations. And also, if you are a developer of a planning engines, it also allows an easy way for you to experiment on a realistic problem coming from the use cases and to adapt your planning engine to one specific use case. So that's, let's say, the grand vision that we have within the project. And this grand vision needs to be, let's say, integrated with AI for AU. So in particular, here we have a different representation. We have the UPF, the Unified Planning Framework, in green. Then we have the technology-specific bridges for the different application. What we would like to have within AI for AU is to expose this UPF as a service. So to allow you to experiment, again, as we mentioned, also training is a very important thing that we would like to pursue. And so it will be nice for you to experiment using the experiment environment within AI for EU, using planning technologies, and also see how we tackle the different use cases within the project directly within the platform. So the idea will be to expose the AI community, through the platform, to the different planning use cases, show them how we tackle them, which technology were covered by our project, how we covered it, so that if a new technology arises, it's possible to write a new technology specific bridge, and to have all this information exposed to the user to AI for EU. That's, let's say, the concept that we proposed, and we got funded by the EU for realizing this concept. This is the set of partners of the project. We have, as you can see, 7 research institutions, some universities, some RTOs. Interesting thing is that we basically covered most of the research on planning in Europe. And we have several companies, as you can see, 7 of which bring us interesting use cases, the one that you saw in the previous slide. So, coming back from the use cases, what we would like to do in this project is to really do, a user-centered kind of design, right? So start from the user needs, looking at the kind of problems that arise in these use cases, and then from these derive what does it mean to create a unified planning framework. So that's the kind of approach that we are following. And in order to create a use case, this is the key question that we asked our partners, and that we also asked outside, in order, thanks to the Cascade funding, to the open calls. So the idea here is that, well, planning is a decision-making technology, as I was saying at the beginning. It is suitable for automation and optimization. The key questions are 3, essentially. So what is the decision that needs automation or optimality? So if you are in a factory, right, among all the kind of decisions that you have to take in a day in order to make it work, what needs automation, what needs to be optimized? Because not all of them probably need automation or need optimality. Some of them are simply obvious things that you do by yourself, or some other you simply don't want to change for your own reason. And so the key question that you need to ask in order to create a planning use case is, okay, but what really needs to be optimized, or what really needs to be automated? Second question is, what data is available in order to inform this decision? Okay, so if I have to optimize a decision, I need to have all the information in order to make an informed decision, right? Otherwise, I'm guessing. And important point concerning the data is whether some characteristics are constants. So, for example, if you are in a warehouse, probably the shelves in your warehouse don't change too often with respect to the position of boxes of pallets that are probably constantly changing. So you need to characterize what is the part of the problem that is fixed with respect to the changing part. Last question is, how often is the decision, does the decision need to be taken? So if you're organizing, let's say, the working of people inside of a factory, right? Maybe you need to take the decision, I don't know, once every 8 hours. So you're organizing, let's say, a work shift. Instead, if you are in robotics, then probably you need to have quite a close loop with the planner in order to update your decision when new information comes from the sensor. So also there are different kinds of planning and planning techniques to be applied depending on how often and how optimal the decision needs to be. Okay, so that's the key question. So I have a couple of examples to make things clear of what we mean by planning and what we would like to do within the project. Both of them are from partners that we have on board of the project. One is from Meritor, that is a company that has a very big production plant in Sweden. They build track axles, as you can see in the picture here, and in particular, they build all the gears inside of the track axles. The problem there is that you have very expensive machines that need to perform very precise operations, and different, let's say, products, so different axles require different ratio, for example, of the gears. So you have batches that need to be prepared well in advance, because the kind of treatment that they do requires several days in order to construct an axle. So you need to be very careful in laying out the operations to be done in order to achieve a certain production, because if you fail to do a proper planning, then you can be late by several days. Essentially, if you forget to create a certain piece, or you overproduce a certain kind of gear but you underproduce another one, then you are in trouble, because you cannot then assemble all the pieces, the final pieces that you need to produce. Okay, and so here the job of the planner, the decision to be optimized is how to allocate the job of the different workers and the different machines. The data in input is what needs to be constructed, what is already present within the warehouse, and what is the schedule of arrivals for the raw materials from the, let's say, the input material that the factory elaborates or works on. And finally, how often they are typically aimed at optimizing an entire shift. So what they want to do is to organize the work given the amount of orders that they have, and they do it roughly once every 8 hours. So that's the idea. Another completely different use case comes from Magazzino, that is another partner. They are a startup in Germany, and they build the robot that you can see here in the picture. Is a robot for logistics. So essentially, you have a logistic setup like the one in the picture. So you have shelves with the items on top, and you want to automate it by putting robots instead of only humans moving around, picking and placing objects. The interesting point of their use case is that they don't want to use planning in order to do automation, right? To automate the program of the robot, because they already have very nice programming there that is already in place. It works very nice for them. What they want to do is to debug this program. So given a certain state of the system, they would like to know whether they were able to cover all the possible failure conditions, they were able to cover all the possible contingency that might arise, because otherwise the robot might get stuck, right? When posed to a condition that was not programmed for, the robot simply stops. And so the idea will be to debug the current programming that, as you can imagine, is quite complicated and contains a ton of branches, and to use automated planning in order to automatically find a way to basically break this program. So we are using planning in reverse, not to construct good programs, but to find a good, let's say, set of events in order to break the current program. That's a very interesting and different use case. Also here, the data that we have is the sensing data of the robot plus the existing program that needs to be debugged. We need to do this offline, so it's basically like a one-shot invocation of the planner, differently from the previous one, when you need to refine an existing solution over and over. And yeah, so this is the kind of problem that Magazzino have. And we have different others. From the consortium, we also issued recently an open call in which we discovered 3 more interesting use cases. And so we are very happy that we are, let's say, broadening the view and the landscape of use cases for planning. I would also like to, let's say, advertise a little bit the work that we are doing in constructing this unified planning framework. So what it is concretely. So concretely, it's under development, but it is a Python library. The idea is to seamlessly invoke a portfolio of planning technique. Important point, as I also mentioned for Magazzino, it's not only plan generation. It contains, for example, plan validation. It will contain replanning. It will contain repair, and so on. The idea will be to have sort of a parallel of what is possible for machine learning, so like Keras or PyTorch, but for planning. That's the aim. That's the ambition. Okay, it is permissively open source. It's under Apache license, so you are very welcome to try it out. It's currently under development because we started just this year to work on the project, but we are proceeding quite well. And here on the slides, you can see the link on GitHub where you can find all the information and the available code. And I would like to point out two things. One is the kind of integration that we have in mind for the AI for EU platform. After all, we are at the AI for EU Cafe, so it makes a lot of sense to present what we mean by integrating planning into AI for EU. So the first kind of integration that I also mentioned before is to integrate the UPF as a service. So in particular, we would like to extend the experiment subsystem of AI for EU to allow you to experiment with planning. So the idea will be to drop down a certain planner, drop down a certain data source that may be useful to create a planning problem. Then you need to drop a technology-specific bridge for that specific technology that you want to address, right? And by connecting them graphically on the experiment platform, you should be able to, let's say, run a planner, analyze a solution, and create, let's say, an AI pipeline that might also contain machine learning components in a matter of clicks, and to experiment with these. Second, we would like also to, let's say, present small-scale demos, small-scale experiments to the general public of AI for EU, for example, by using Jupyter notebooks, as, for example, is very commonly done for tutorials in machine learning. So the idea will be to interleave explanation and tutorials together with code, with actual Python code that you can run, and to make it possible to run this Python code also online, so that the user can interact, can experiment with the implementation, see how a planning problem is modeled, it is posed, how we can move, let's say, from the data for a certain use case to the planning problem formalized, right? How can we invoke the solver, and how we can read back the solution. That is again for training, but also for, you know, sort of a informal documentation, because sometimes it's better to experiment and play with things than reading a manual of 600 pages. So that's the kind of use that we foresee for the use case integrated as a service. Second, our ambition is for the UPF to be actually, let's say, usable in production. So the idea will be for the UPF to be usable as an abstraction library that allows you to actually experiment even on complicated problems that requires significant computational resources. Clearly, we cannot provide these computational resources directly on the platform, but we can exploit the catalog of AI for EU to serve the UPF, so to present the UPF as a downloadable resources and to guide the user in its usage by means of tutorial, by means of documentation, and to make so that a user can download the UPF and execute it using his own, let's say, computers or cloud resources. This is in particular needed for closed loop applications such as robotics, right? You cannot imagine that the planning of a robot happens on the cloud, then each action, once decided, needs to be, let's say, transmitted via the internet. But also for other, let's say, more computationally demanding problem, like in logistics, we cannot possibly provide the computational resources for free on the platform. So the idea will be to exploit the platform as a sort of showcase and to allow the users to download and experiment with the UPF themselves. In addition, the training, the planning cookbook, the Jupyter notebooks will all be material that will stay on the platform and will create interesting links also with other kind of planning of AI technology, right? For example, in robotics, maybe there is the connection between how we perform the sensing to the planning problem that we construct with the sensing. So maybe there is a link with computer vision and so on. And so we can use the platform to create all these connections, this network of communication. So this is an overview of the project ambition, of where we are right now. The last thing that I wanted to share with you is the possibility of interacting with us. So in particular, we have an open call program that is, let's say, a very important part of our efforts to scout for use cases, and scout for additional technologies. What I mean by that is that we have 3 calls for additional use cases. One we already closed, it was issued, that is April, but one will be opened next month, a third one will be opened in February 2022. The objective of these calls is really to elicit new use cases for the planning technology to be included in the project. So the idea will be to scout ideas for using planning in innovative way, or a different twist on an existing use case, or simply proposing a new domain where planning was not applied before, or that we don't have currently in the project. Let's say the value for the project is to make sure that the UPF requirements are as general as possible, so that to evaluate the generality of the approach, but also to serve as training material, so to present the kind of the use case as a sort of, by the way, planning can also be used in this domain. And these open calls are very, let's say, simple, in the sense that we are asking people to present their use case by answering the 3 questions that I presented before. So what is the decision to be automated, what is the data that is available, and how often the planner is called, basically. And the idea is to organize workshops with the open call winners and the whole consortium and the community of AI Plan for EU, so that we can discuss, analyze, query about the characteristics of this use case, and see the possible connections, see what is interesting, what is not interesting. And so this is a very interesting, let's say, opportunity for those that are maybe new to the technology and want to discover more. And it's also very important for us because it informs us on where to invest, because we have, let's say, a limited amount of money for the open call for use cases, but because we invested most of the available money for the second kind of open call, that is the open call for innovators. So given the information that we have about interesting use cases, we will issue 2 open calls. One, again, will be next month, the second one will be next year. And here the objective is really to ask people to develop either new planning engines or to cover new technologies with technology-specific bridges, so to create a bridge between our UPF and a certain technology that is relevant, or to present and experiment with new use cases. So not only, let's say, describe the use cases abstractly, but also to experiment with it. And here we have substantial funding to let's say, to subsidize sub-projects. And for the open call winners, we have like a 7-month program, that is, we call it the I Plan for EU Sprints Demo program. So if you apply and you are selected for this open call, you will be asked to develop a certain artifact, so either a new engine, again, a new technology, or to experiment with a new use case. And you will be also in touch with the rest of the consortium, so you will get a 2-month sprint with different objectives, so that we can see and guide you also in the use of planning technology. I think especially for startups, innovators, or even big companies that want to explore the use of planning technology, this can be a very interesting opportunity that we have. And so this is an overview of the project. I thank you very much for your attention, and I'm very curious to hear if you have any question or curiosity. Thank you so much.
Thank you very much, Andrea. Thank you very much. Very interesting, and it's a good start for the cafe fall season, because I mean, there are open calls coming. You just talked about open calls, and there comes also the question, and I hope also the participants have questions. How much money do you give to people who come in your open call, first for the use cases, and then the second group for the innovators? What is the budget?
Right. So for the call for innovators is where we have the substantial money. So we have 60K for developing new technologies, so for covering new technologies, so developing technology-specific bridges, or for contributing additional planners. And we have 30K for the experimentation part. Instead, for the open call for use cases, you know, we wrote the proposal in a pre-COVID era, And so the idea there was to give money to come to us to have a physical workshop meeting. And so there we have 1,500 euros that was intended just for covering the travel expenses. You know, we had the first one just last week, and unfortunately it was, let's say, online. So, you know, the motivation for that one is not really the money by itself. It's more the opportunity to interact, you know, with the panel of experts that we have within the project and the other companies that have experience there. Really, the aim that we had there was to, let's say, let's cover the travel expenses. Let's create a workshop that you can participate for free at that point. And yeah, so that is the money.
Okay, so I understand that that even a single student or entrepreneur could say, hey, I have a cool use case for your technology, for the planning technology, and then I would just send this in, answer the 3 questions, and then I would basically participate.
Yeah, that's exactly right. So
if I'm lucky, I participate, and I might even be the lucky person who later even wants to experiment or provide technology. Maybe I can do everything, but to start off, I could just answer 3 questions on your website, or where is it? Where do I
well, when we issue the open call, so we will issue one next month in particular. There is essentially a template document to fill out and a very easy online application on the website of XSS. So all the information is on our website that you can find it here. iplan4you-project.eu. Currently, we don't have an open call that is on which you can apply right now. Next month, we will open one, and you know, make sure to inform you all about this opportunity. But yeah, it's a pretty simple procedure, because you need to fill out a form, you know, with all your personal information, legal information, and blah blah blah, plus filling out a template document. That's all we ask. In exchange, you get the participation in this workshop and 1,500 euros.
Okay, and then also, as we learned, there's another, if I right away have already technology, and then that is the other call I would go for the innovators, no? Just to recap, because to make so it's all possible, and practically a person who's interested checks in October on your website, no? All the when you
perfect, yeah,
open the call. Okay, so now we got that. Here comes a question from a participant. First question is more connected, still to the open call. Muhammad Imran, I'm PhD student in Italy. As individual, can I apply for second open call?
Yes, absolutely yes. So it is eligible every physical or legal person established within the EU or affiliated country. So if you are in, let's say, in the EU, yes.
Yes, he says he's in Italy, no? Student in Italy.
Yeah.
So he must be, maybe he's even close by. So yes. Okay, now another question. It's a little bit different. It's from Boris Baldassare. Thanks. That's really interesting and a great addition to the open source resources set and to the AI4U experiments framework. My question is, how will it be made available in the AI4U platform, in the marketplace, as pipelines, or as a complete tutorial to demonstrate the full tool chain from source dataset to results?
Right. I think this is exactly the kind of question that we are answering between our work packages. So to answer your question, first, we definitely will expand and provide contributions to the pipelines of experiments. So right now you have the possibility of dragging and dropping machine learning components. We will add also components for planning and data sources for planning. So that's our first addition. Second, that is a little bit more, let's say, less currently supported. We have to do a little bit more work in order to make it work. Is to have, for example, a Jupyter notebook directly presented on the AI4U website, so that you can have, a little bit of text explaining you what you are seeing, introducing the kind of use case, and having the actual code that maybe with some synthetic data, right? Because you don't maybe want the AI for you website to create a connection directly with your factory. In reality, maybe you want a simulated system. And from the data, you create a planning problem. And you can learn by reading the explanation and by experimenting with the code how we derive the planning problem from the data. That is the two most, I think, interesting kind of integrations that we have in mind.
Okay. Okay. Thank you. And now I have another question for you. And that's Jasmin. Jasmin Grosinger. Thanks for your interesting talk. Could you explain me more detailed the diagram of the UPF? How are you going to implement an example technology bridge concretely?
Okay, perfect. So I can maybe go back real quick.
Back to it.
Probably like this. So the idea is this one. A technology specific bridge for us will be a piece of code that is specific to a certain technology. So to make it more concrete, suppose again that your technology of reference for your application is ROS, the robotic operating system. ROS has a set of interfaces that allows you to query, for example, the available action of the robot. It has some features in order to do some state estimation, so to understand where your robot is and in which state the different components are. And so the job of this piece of code here that you can see in gray, so this is ROS, right? The technology that is relevant for your application. Here, the job of this piece of code is to interface with ROS on one side, so to read this information in and to provide the, let's say, to act as a ROS node in particular in that case, so to also be callable by the technology of choice, so by ROS in this case, and to create a planning problem, solve a planning problem, and to expose back the solution to ROS, so to for example, issue at the right moment the commands for the robot to move in the technology. The point is that the overall idea is that the green part, so the unified planning framework should be general purpose, so it should not be customized to any specific technology, but we recognize the need for interfacing diverse technologies with planning. So the job of the TSBs, the technology specific bridges, is to create this glue between this general purpose API and let's say the technology that is relevant for a certain application. Can be, you know, a platform by Siemens if you are modeling a factory. There is one tool called PlanSim, or maybe you want to interface with some packages by MATLAB. So there is a wide variety of applications there that might be interesting. And the job of the TSB again is to create a glue, so to transform objects, concepts that are relevant for the technology into general purpose variables, actions, transitions that make sense for planners, and translate back the solution that a planner gives you to the level of abstraction of the technology. I hope this was clear enough.
We see if Jasmin comes back, but let's hope.
Anyway, Jasmin, if you have curiosity, I'm very open. Just drop me an email. I will be happy to also give you code if you want to.
Yes, I think that's the important key on this cafe, that just me, I have to say again. Also, Andrea, our speaker today, is ready for being contacted by you directly. Don't go over me or anything. Go directly to Andrea. And if you need more details, more also about the open calls. And Jasmin says, yes, it was clear, thanks. So yes, Jasmin, great. So, but if you want more deeper information, go there. I personally want now I have a question, because I think you told me, Andrea, that you are basically the coordinator of this project, and it also builds on your research, which you have done before, your research work. What is you personally, what excites you? I mean, what's the most interesting research question? There's so many partners, there's so many exciting things, but what interests you?
Right. So this idea was exactly based on my own research, and in particular, I tried to combine two past experiences. So on one side, I did a similar thing to this one. So the idea of creating this abstraction layer for different kinds of solvers for a different area that is called satisfiability modulo theory. So it's another thing compared to planning, but I created this library that is called PySMT. That is conceptually the same thing. It's a Python library that abstracts away the capabilities of every single solver and allows you to create the problem once and to select the solver that so test before you buy very cheaply. And it was quite successful. So it's there. It has it is quite used in the SMT community. The second experience is actually a project. So here in FBK, we work in European projects, in publicly funded projects, but also we have consulting with companies. And there was this company coming to us and posing us a very, let's say, simple problem in a sense. So they had this process. It was a galvanic process, so coating things with metal. And the idea there was to automate the production line. And so to make a long story short, we basically worked for like 2 years in order to make planning work for that specific problem, because we couldn't, let's say, reach a sufficient level of efficiency. So we quickly discovered that there was quite a big hole in the literature, right? And that we were quite detached from the needs coming from the companies with the research that we were doing. And so this project is a trial to, let's say, merge these two directions and hopefully make a good impact for the European industry and, let's say, domains in general.
Yeah, it's super interesting because it's driven by real content, real motivation coming from a company asking for help. This is like the typical setup everybody wishes. A company comes to research organizations and can we sit together, solve this problem. And it's just a good example because just whoever is listening and to all the researchers out there in Europe and everywhere, it's really great to come with these applied problems and then using also these kind of use case, projects, European projects, even open calls, to solve them. I think that's a very good example. And I would like to come to my final question for today. You made it, but what can you say to get more students who are a little bit younger than you or young entrepreneurs going into testing, piloting AI? There is still not yet enough movement out there. There's somehow not enough students and not enough entrepreneurs, young ones. What would you suggest? What shall they do to get into the field?
Right. So it's a very good question and probably a very hard question also. In my opinion, there is essentially two problems or two important, let's say, directions. One is the fact that AI is a very big term. So, for example, planning is definitely part of AI. Is probably one of the first problems that was recognized as an artificial intelligence. What does it mean for a system to be intelligent? And still is, let's say, underrepresented because now we have this big buzz because of the great successes that we are having in machine learning and deep learning technology. So one suggestion is try not to focus only on the hype, but also try to have a general view of AI. So AI is multiple things, and I think the coolest thing at the moment is the combination of the classical AI with the new deep learning methods. So don't, let's say, focus yourself and exclude everything that is not deep learning. That's one suggestion. And second is try it out. So it's sometimes you think you know something because you read about it, or because you had that course at school. But when you try to code or to do some examples, right, of actual programs, you realize that you probably don't know it, right? It happened to me in machine learning, right? I know what it is in theory, but until you try it out with your own hands, you don't know it.
Yes, Very good. I think this is super concrete. That's great answer, great also motivation out there for everybody. And I will for today say we have now all the questions answered. Our friends out who are in the public are happy. So I can only thank you again for being here. And I have another nice cafe just on Thursday. Tomorrow is also a nice one, but on Thursday I just want to jump there because it's also from Italy. As Andrea is from Italy, then comes also Claudio from Italy, and he does Project Vinum towards automated pruning of grapevines. I like this idea. It's like he is on the grapevines. I mean, how to solve this specific problem. So if you even want to know more, come there. And tomorrow we here, and if you like, tomorrow we have 3 cafes this week to start the season. Tomorrow we have enabling AI and Earth observation innovation, integrating AI platform with DIAS platform. So if you are in Earth observation, so less than wine, but more Earth observation, and it's tomorrow for you. Tomorrow we have Anne-Kathrin Devin and AI for EO. So that's complex. Anyway, I'm really inviting you also to become speakers. I cannot say it 10 times more. If you feel like inspired to share your great project or your great problem or your great innovation, whatever you like to share, please notify me, write an email, send it to me. And then I say thank you. Andrea, thank you. And
thank you so much for having me.
Have a nice afternoon. No? And bye-bye. Bye-bye, everybody. Bye-bye.